My name is Jim Marcelli. I'm the president and COO, used to be CEO, president and COO of Lightwave Logic, and I just am here to do a presentation about our technology. Our typical safe harbor statement we have to put up. Anyway, so Lightwave Logic, we have a technology platform that's using electro-optic polymers, and what we're doing is we're designing to help the scaling of the existing internet structure. And what we're doing is what we're developing is materials that can do, we develop materials that can do higher speeds at much lower power. And we're leveraging those materials and those devices that we're developing to convert electrical signals to optical signals. And right now we're basically in the evaluation is underway on our Tier 1 customers. And we have at one point we had operations in Delaware doing our chemistry, and we had an operation in Colorado doing our device design. But we've now, in the last year and a half, we've combined that into one operation in the Denver Tech Center. So we have both all our chemistry group and our design group are in one house, so they can, much better for communications, much quicker for feedback, much better for all of our test results and everything. So we have all the fabrication is in-house and design is in-house. We have a really strong balance sheet right now. We have an agreement with Lincoln Park Capital. We have about $19 million left on a $25 million line. So we have a strong balance sheet, clean cap table. We basically, other than some warrant overhang from a couple of PPMs in there, that's it. We have no debt, zero debt. We have a very strong IP position. We have actually 47 patents right now that cover both our materials and our device design. And what we're really trying to do is trying to take the existing infrastructure that is being stretched, and quite frankly, and is jamming traffic. And as you know, obviously, between cloud computing and between all of the video streaming that people do, and now it was just Netflix. We're not just Netflix anymore, right? Now we're talking about, we've got Amazon, you got Disney, there's a number of people, and it's putting a ton of pressure on there. And the data centers and infrastructure, they used to be 3 gigabits per second, 10 gigabits per second, 40 gigabits per second, then do to 100 gigabits per second. And what we're doing right now is we're designing stuff that is going to be in the 800 gigabits per second and up to 1.6 terabits per second is what we're working on, because our bandwidth is such, which I'll go through, and is that we've been able to increase the bandwidth, and we're doing our gigabaud, we're 50, 70 gigabaud per second. So, and the markets is exploding. I mean, the fact of the matter is that the growth in the markets for these devices, photonic devices, has really been increasing. It could be about $44 million by 2025. And they really need, radical innovation to take care of the future needs for data transfer. And we're working with our EO polymers that run at several different wavelengths that will allow us to do that. And one of the things that, without getting into too much in the technology, we can do separation, as anybody knows, on a single fiber. There's different colors, so what you do is just do a separation, so you can have multiple channels and use separation for as low as 25 nanometers. Most of it's about 50 nanometers, but we're working to get down to 25 nanometers. And so again, what we're trying to do is we're starting with the fiber communications at our current technology, and to go after the internet structure, because that's the biggest market right now. And what we're really trying to do is we think we can do much less power and with a lot more throughput. Most of the devices right now that are in there, the transceivers in there, are running 6 volt. And sometimes in higher, but 6 volt. Right now, what we're developing with our materials, we can get our voltage down. We're at about 2.4 volts right now, but we're going to be down to less than 1 volt. And with less than 1 volt, that saves a ton of power. I'll tell you a little, just quick story. I had going because I was just there. I was in New Mexico visiting a data center construction that's going on. And there's a company, and I probably wouldn't appreciate me naming the name, but there's a company doing 4.5 million square feet of data center just south of Albuquerque. And 4.5 million square feet. So if I have a friend of mine, that's what he's got a 13-year project putting this together. So anyway, he invites me down, and I go down there, and he shows me the first building they just released, and it just opened up. And then first thing you know is he goes by this unbelievable power, substation. And he says, this is the first thing we had to do. We had to build this huge substation to be able to support the power that's needed for the 4.5 million square feet of data centers that they're going to be putting in. So anything you can do to be able to lower the power, and basically we can get down to 1 volt. Even what we're doing now is about 26% less than what people are doing now as far as the power usage is concerned. And we can get down to 1 volt that does a couple different things. It allows us to not have drivers in the modulators, and it would save a tremendous amount of power. And with that is heat, right? And that's one of their big battles too in these data centers, is trying to get the heat out of them. So anyhow, it was quite interesting to go through and see firsthand of the building of these huge data centers. And again, the proprietary part of our business is the EO polymers. When I first got involved with the company in 2008, believe it or not, and basically the founders were just trying to develop electro-optic polymers and thought that they could wheel out 55-gallon barrels of polymer. And when we got involved someone got involved in the company, we said, no, these guys are out of DuPont, so they thought you just basically do material. And so no, we got to go up the food chain, and we got to be able to design devices that uses this enabling technology, and that's what we're doing. So again, I touched on it a little while ago. Fact of the matter is this incredible energy savings with what we're developing, much faster networks. Again, you want to work with existing structure, so you're just taking the transceiver and replacing it with a much faster transceiver, so that they can increase their bandwidth and multiple times of what they're doing right now. Like I said, what we're developing is right now would be 800 gigabits per second. And the flexibility on the engineering side is a whole lot more. It's a lot more flexible developing these chromophores. The chromophores are the dyes that we're developing at different wavelengths to control the optical loss of these materials, and then put those materials into a particular design to support either the internet applications or the telecom applications, and for those you have to use different wavelengths. The targeted, basically targeted and very large targeted markets that we have. Now, where we fit in this thing is we have to sell. We are selling to several different areas in here. We really trying to look. We're not going to get into the transceiver business ourselves. What we're doing is developing a chip that would fit inside these receivers, the chips that are modulators will fit inside the transceivers. So we would be going to the companies in the second box there, the high-speed optics manufacturers that we're trying to design in there. We do with network equipment. We sell into network equipment, but the main thing that we really spend a lot of time on is the influencers. We say mindshare, but the internet providers that are listed there, plus other companies, the Microsofts of the world, the Apples of the world. We're sharing with them what our new technology is and what we bring to it, and they're pushing the other way. They're pushing away to their suppliers. Hey, you really ought to take a look at this technology. So we're selling into the actual internet service providers, as well as the network equipment manufacturers and the device manufacturers. Because again, if we can get designed in at the transceiver level with our chips, with the high-speed modulators, I mean, once we're in there, and that's what we're pushing is to get into the optical component supplier market. We don't want to be the ones building 50,000 of these a month. There are people out there doing it. We put our chip in those things, and then they produce it. And with that, while we have the three-prong model, that selling components or product, we also have a licensing, because we have, like I said, 47 patents, both to cover the materials and cover the device design. several different device designs, so for freedom of manufacturing. But frankly, if we get designed in, what you're really talking about is technology transfer, and we think that's probably the biggest game for us, is the technology transfer. We will work with companies that design in our chips into their devices, and once it's locked in, we work with their engineering groups, then we're locked in. In some cases, we're working with a couple of we're under NDA with a couple of large potential customers that would rather just look at licensing the technology. But I still think that probably while we have a multi-pronged business plan, the fact of the matter is I think the technology transfer is going to be the biggest one for us. But right now, like I said, we've got several NDAs. We're doing prototyping of these different devices, and then what we do is we take these prototypes and we let the potential customers look at these, run their testing on it, come back to us, whatever changes that they think we should make, and then we'll make another run at those. So basically, we're doing alpha and beta type product for them to test and run through the gamut of tests that they need to do. I said today we have 47 issued patents right now. We probably, based on what we think we're going to probably be somewhere around 53 to 55 patents by the end of this year. We also bought all the polymer business from a company that was owned by Gig Optics at one time. Lumera was called BR Photonics out of Brazil. They went a different direction, and we ended up buying all the patents, because those patents, along with our patents, give us total freedom of manufacturing to get our hands on them, and we were able to get those at a very, very fair price. Let's put it that way. But again, so we cover both the EO polymer materials as well as device designs. The other thing, we have a very, very good seasoned team. Michael Levy, Dr. Michael Levy is the CEO of the company now. He's a technologist. And then our chairman is Rear Admiral Zellebor, who's been involved as long as I have with this company in 2008. But we have two unbelievable, we have a whole great team I mean, our board is like unbelievable for a company like ours. But we got Dr. Joseph Miller, who is the Senior Vice President and CTO of Corning Corporation. And so he's on our board, continues to be on our board. He was the CTO of DuPont and CTO of Corning. And then Dr. Fred Leonberger, who's basically the father of modulators and lithium niobate design, known worldwide. He's on our team, and he and I have been working together on this since 2010. So we got really a whole team of believers that we know we can make this happen. And then Suraj has Minar, so he's a network equipment supplier, and he's on our board as well. And anyway, like I said, we got an incredibly talented team of people. And then in our design people too. We're a small company. We got 18 engineers and scientists in the company right now, all in Colorado, between chemists and by the way, most of them are all PhD level people. Between chemists and device design people and fabrication. So we actually fabricate the wafers at our facility. So we can do all the prototype fabrication right there. We use both 3 and 6 inch wafers. And the other thing, we put together a world-class advisory board that are involved in a lot of these companies, or were involved a lot of these companies that we need to get into. And so these people really know their way around. And they've been incredible help at helping us in the direction that they think we should go, and helping us on the design end phase of this thing. So we just have, like I said, an incredible team of people. And again, I think the key takeaways on this is basically we're trying to scale up into the existing infrastructure with our enabling technology. We're not trying to redesign the infrastructure. We're talking about something that's a plug and play, but at a much higher speed and lower power consumption. And that's, I mean, we're getting a lot of interest for that. And basically we're leveraging all our electro-optic polymer designs that we've done. And the other thing, again, not that I've said it earlier, but I'm repeat it anyway. We have total control not only design but the manufacturing of all of our polymers, all of our EO polymers, and so which is incredibly important to keep that in house, because that's the enabling technology that we're using. Again, I think that, and again, the market keeps continuing to grow, and it's sitting at 26 billion now. We think it's going to be up to 44 billion by 2025. And again, the evaluation is underway right now with Tier 1 customers under NDA. I mean, if you're in my position, you'd love to sit up there and go and rattle out the names of the people that you're working with, but they frown on that. They don't want you to do that. And in fact, I can tell you, a few years ago, we put out a press release, and I got a call from one of them that says, "That's too close. People can figure out who you're working with." You know, they kind of slapped our wrists and said, "Don't put another press release out like that." Anyway. But we're very happy about where we are right now. Obviously, we always like to go faster. You always want to go faster. But right now, like I said, we get some really good Tier 1 people that we're working with. And with that, I'll just open up to any questions. I was trying to spend, anyway, time to.
What's the sales team about?
Pardon me?
The sales team.
The sales. Okay. Well, the sales team we have a woman is our VP of Sales and Marketing, who comes out of the industry and knows all of these people, and she can get in there. But not only with that, we have, quite frankly, we enlist our board of directors and our advisors, and to get into those same people, right? So we don't want to be spending a ton of money on sales and marketing people right now with the development stage we're in right now. But however, with our board, when we put somebody on the board, that's one of the things. How can they open doors for us? And that's what those people are, you know, the Fred Leonbergers and the Joe Millers of the world, and the Sarai, these guys can open doors for us. Same thing with our advisory board. They've opened a ton of doors for us. I mean, you know, they can just make a phone call and we're in there. So that's who we're using to do that. Yeah, we had a $25 million line, and we're down to just 19 and a half or something like that, which is public, by the way, because we just did an S1 on rejoin. Yeah, so I'm not telling. Pardon me?
Market a positive, negative reception?
Well, I think we get some people complaining about that structure, right? However, I can tell you something right now, and I should put a slide up. When I started with the company, we had 35 million shares outstanding in 2008. We have 87 million shares outstanding 11 and a half years later. All right, so dilution is not something so I think, and in fact, I did a couple of case studies on other companies that have, and I said, if we followed that model that they did, I'd have 250 million shares outstanding, and those, and I don't want to name, it's not fair to name it, but their stock's trading at anywhere from 18 cents to 31 cents a share. You know, I think we picked the right instrument. We have no debt whatsoever, no convertibles. We don't do any, and I think at a company our stage, we shouldn't be doing that, to be honest with you, any sort of convertibles. So yeah, we still have a couple of years on that line and about 19.5 million. Yes, sir.
Direct competitors and who are they?
Well, it's funny. The direct competitors. Well, first of all, when you say competitors, we're not going to be competitors with the transceivers people. We're going to sell to the transceiver people. So the competition is really the indium phosphide people that are using indium phosphide, or using gallium arsenide, or using silicon photonics. That's the technology that we're competing with. But we know they have limitations. So every one of those have limitations, and so that's why we think we can win. So we're really not. That's what we're competing with, different enabling technologies, not the transceiver people. We're selling to those people. Those people be our customer. Go ahead.
Are you saying that from a materials standpoint, you're unique?
I think absolutely we're unique. And the other thing that allows us, one of the reasons we have a higher bandwidth, and we're at 50 to 70 gigabaud compared to other materials, is because of, it's called velocity matching of the electrical signal and the optical signal. You can get that matching with polymers that you can't get with some of these other materials. And so that's one of the reasons why we can get a single channel at 100 gig. So. Geez, we haven't officially announced that. Obviously, we're moving as quickly as we can. We're going through the process right now, like I said, with the tier ones of evaluating the alphas design. So as soon as we can move through that, then then the next step would be getting into the design range. I mean, into their full designs. And we know, even though I can't share about how far out those people are on those new designs, the stuff that we're working with them on, we know where that is. While it's further out than I'd like, it's not terribly far out. But we haven't, as a public company, we haven't made that announcement, and I probably shouldn't be saying that here.
So you are fabricating, though, the circuit, the parts, they're silicon based, you know, you've got this material, so your parts are silicon based at all?
Well, we can do two things. We can do full plastic, if you will, right, the polymers, or we can use substrates that are a silicon oxide or oxide wafer, and then build it up from that, right? So when we fabricate that in-house, we get the wafers and we fabricate the rest of it in-house. Okay, so everything from gold deposits to depositions, I should say, and all the fabrication. And I said, we're set up to do 6-inch wafers, and obviously you can get a lot of devices on a 6-inch wafer. On the prototype side, quite frankly, we use 3-inch wafers because it's a lot easier to use the mass sets, if you will, in the beginning with 3-inch wafers. So, but anyway, that's. I apologize, I can't really tell you where I know where I think we're going to be, and we're excited about it. Let's put it that way. But we're not ready to announce it. To me, the other side of it, until the potential customer is there with a design and go, then we really.
The parts you've replaced, how much are those a year? I mean, what is that market size?
Well, they're building. I mean, peeling out the design, how much of that? Well, I think that we'll probably be about 30% of the market. The cost of the market, I think our opportunity is about 30% of that.
And is that, I mean,
Okay. So I guess what I'm trying to say is, for us, it could be, well, the overall device market is we're going to be at 44 billion. I think if we get to design in our section of it, that's probably closer to about a 10 or 11 billion dollar opportunity TAM for us. Yes, sir.
Is this a one-time point of sale, or is it recurring revenue?
I'm not sure.
is it reoccurring revenues or a one-time?
No, it would be reoccurring revenues, absolutely reoccurring revenues. Yep. Yes, sir.
Where did the technology come from, and
Where it came from? Well, historically, first of all, EO polymers have been worked on for years, right? There was a lot of companies, the DuPonts of the world, even Corning, a lot of companies worked on EO polymers. And in the early days, they weren't terrible. Two things happen, right? If the market's not ready for it, okay, and lithium niobate was just starting, there's no real need for it. The second thing, so they got it to a certain level. The materials, the polymer materials weren't as stable as they should have been back in 20 years ago, 30 years ago. And we've gotten over those humps. We've been able to deal with all of the stability issues that people around. When I say stability, I'm talking about thermal stability, because you have to pull these materials, and then under temperature they could come depole, for instance. But we've come over that, and we've tested them at 110 degrees C. And we put out press release before on that. So 110 degrees C is more than enough to be very stable material. And photo bleaching is the same thing. Anyway, yes, sir.
You told us you have significant technical advantages over other materials.
Correct.
If you try to make a sale and you lose the sale, is cost a factor? Or they just don't need your advantages?
I don't think well, cost won't be, for number one, won't be. I think they can get to a certain point today and they hit the wall, speed-wise, okay, and power-wise. And I don't see, I know maybe, maybe I'm just too positive on it, but I just don't see how they're not going to look at us. They know they hit a wall with a certain technology. They can get around certain things, certain part of it on the electronic side, not the optical side, that make up for it. But then there's a point they still hit the wall. So can they push it off for another year or two before they really look seriously at it? Yeah, I guess they could do that. But that's not what we're seeing from people. They understand where what the wall they're going to come up against, and they're coming up against it fast. So, okay,
So implicitly, you're saying you have unlimited opportunity?
yep, we just need to execute. That's the way we feel. And I think that's the reason why the team of people we have and the team of people we have both as advisors and on our board of directors is so excited about the opportunity.
So you're basically saying they've taken your devices, put them in theirs, and they've gotten this tremendous performance results in their labs. Already, they've gotten results.
Well, I didn't say that, right? I said they're doing, I said they're making, that's what we're doing. The tier one customer, we've given them devices and they're testing those. We did internal testing ourselves, right? Because we want to make sure it's doing what we're thinking before we give it to them. But I'm not here to say one way or the other whether or not they're finished doing their testing too.
And what do they see that's wrong? I mean, they probably give you feedback about problems that are potential problems or concerns, you know, they have.
Well, most of the time, I said earlier, what you can do is, for instance, data centers, they run at 1310, right? That's the nanometers. So they'll come back to you. So we give them a device at 1310, and they come back and say, hey, can you do 12? Okay, never mind. I guess I'm done. We can talk afterwards. Thank you.